Good evening, ladies and gentlemen. Thank you very much for giving me a voice. I will today talk about hydrogen production from brewer's spent grain. My topic is based on article published in International Journal of Hydrogen Energy titled Hydrogen Production from Brewer's Spent Grain Hydrolyzed by Fermentation. The work was written by a team of Professor Mazzutti from Santa Maria Federal University in Brazil. The research is using as inoculum as a bacteria from Solosky treatment plant and as a feed brewer's spent grain. The reaction is checking how it will be made, how it will process. The bacteria were pretreated by acid hydrolysis, and this hydrolysis was after nutrient feed. The bacteria were heat-treated inoculum. What is for? Heat-treated inoculum is for blocking metagenetic phase of bacteria, allowing stopping the process and allowing only hydrogen production. Because dark fermentation is a special case of anaerobic digestion, where it finishes on hydrogen production and not going further to methane production. The hydrogen production is the good replacement for fuel as a fuel, and very important is to collect a design method, which would be utilization of waste and giving hydrogen as one method. The important is that some waste are very to develop, and biological processes are dark fermentation, photofermentation, biophotolysis, and microbial electrolysis cell. But the dark fermentation is as a process of hydrogen production, more viable variety of ways, giving that in production of all the production and all periods can be changed. And one of these moments is the brewer's barley and beer production is giving much waste. And one of waste is containing much of lignin. And therefore, this is important case to lignin part to isolate and to use the cellulose, and hydrolysis is important part of this method, efficient. And the production of dark hydrogen is using dilute acid pretreatment. So at temperature of 127 for 20 minutes, it was phosphoric acid. Phosphoric acid is different than usual hydrochloric acid and the sulfuric acid. Is less corrosive than sulfuric acid, but is more expensive than sulfuric acid. And due to lack and no phosphor, that is phosphorus fossil is only for Morocco and we have trouble. We need also to design using phosphorus problem how to recover this phosphor from different sources, from waste to make hydrogen phosphoric acid. But here was as to change acid as hydrogen high phosphoric acid, 85%, and diluted to 0.3. inoculum was from slaughterhouse treatment, which contains much of bacteria which are in, for example, in intestine, which is in case of cattle, the production of methane as methane production. So these are, in fact, bacteria which produce hydrogen after pretreatment. They chose 100 Celsius in for 60 minutes, for 1 hour. This is different because usually it's 120 and 50 minutes. He chose to make lower temperature but higher time for checking how it works. And this, the treated inoculum was before using kept in -4 degrees Celsius. Then this land, after acidic pretreatment of phosphoric acid, hydrolysis, and wet basis was only the substrate, was filled in 500 milliliters bioreactor with sterile, was batch process, in initial pH 5 to 5, and finally, however, control was 7.5, going at low, so control of pH was, but they needed to lower from 7.5 because the process was of digestion of this hydrolyzer was shifting pH to 7. So for acidic condition, because documentation optimal pH is 5.5 between 5 and 6, was going naturally to 7, reducing the methanogenic hydrogen trophicity. So we needed to find in brewer snatch with keeping. The temperature was as mesophilic from 35 to 45. They don't have any trouble, but with pH, they need to add as controlling pH was hydrochloric acid. So, however, the solution hydrolyzed was phosphoric acid. The rest in documentation was adjusted by hydrochloric acid and sodium hydroxide. The process is replicated to make replication proper and was produced. As a result, we have from 1 liter of waste, even from 7.07 to 4 liters of hydrogen per liter of waste. This is high on the cassava or starch. This is going higher than other. Only way was cotton with Lee, professor, with cotton using the bacteria from intestine of carpio. But I think that inoculum from slaughterhouse is much more available and can be used more likely in other spreading the culture. This is very interesting, and this showing that in case of hydrogen production and brewer sludge, this phosphoric acid give hydrolysis give better result of sulfuric or hydrochloric acid. This shows that maybe it's more expensive to show they need to show which part is better. What part is better than phosphoric acid to understand. The big was that big inoculum plus 30% give the lower of glucose percent, because they part also measure how inoculum percentage was influenced, and the increase of make that or that more or less more glucose was fed and less arabinose from these cellulose, but still in 10%, the biggest was cellulose, not glucose. So the difference of feed is showing that different of population gives the different concentration taking, that not only glucose, however they have glucose, arabinose, and cellulose, in some time can be glucose, but in case of 30% was mostly glucose, but lower give more likely to eat over, not also, maybe because they need to develop more, and in the case of 20, even to all cellulose was eaten. So this gives that some is cellulose, as some cases in case with grow, we have more glucose. But in low bacteria concentration, the other sugars are better. So this shows that bacteria not eating always the simplest and the thinking the most optimal, but sometimes they digest other sugars. And this is the very important issue to analysis. And this is option to how to provide continuous production to change the concentration of feed waste dependent of population now quality and quantification. So thank you very much for listening to me.